Let's go to page 42 and start with number 50. Okay, so you have a triangle ABC. And AD is the median. So median means it goes through the midpoint. And you want to prove that the given equation. Okay, so again, whenever you have median, what you need to do is you need to extend the median and make this into a parallelogram. Okay. Okay, so let's look at triangle ACM. Call this M. So this triangle over here, and use the law of cosine. So use the law of cosine for this triangle here. Okay. So this would be like your C. So you're going to get AM squared equal to AC squared plus CM squared. So you can C squared equal to A squared plus B squared minus 2 AB cosine of C. So angle ACM. Okay, so this is the law of cosine. Next thing is that if you see the CM is equal to AB, okay, because you form a parallelogram. So CM equal to AB. So this becomes AB squared. Okay. And also AM, see AM equal to 2 times AD. Okay, so it becomes 2AD squared. Okay, so AM equal to 2AD. And again, CM equal to AB. And the angle ACM, so this angle over here equal to angle, okay, this one over here, okay, if you go off to the side, angle ACM equal to 180 minus angle BAC. Okay. So these two angles are supplementary. Okay. So BAC, and when you take the sine, when you take the cosine, so cosine of angle ACM will equal to cosine of 180 minus angle BAC. Okay. And cosine of ACM. Now when you have a cosine, the supplementary of cosine is going to become opposite. Okay, so they become negative cosine of angle BAC. Okay, again, if you draw the picture, okay, so the supplementary, they're opposite. Okay, so that's why it becomes negative. Okay, so this becomes negative, so this becomes plus angle BAC. Okay. Okay, so just be aware of that. Okay, now let's go ahead and square this. So square, you're going to get 4AD squared equal to, and I'm going to move this over, rearrange the order. Okay. Okay, and that's it. So that's the proof. Okay. Okay, let's go to the next one. Okay, number 51, okay, the picture is given. Okay, so you got A, B, C. Okay. And we just have the random lines. Okay, so this is point P. This is X, Y, Z. Okay, so it's the magnitude of the sides of triangle ABCs are A equal to BC, so this is A, and B equal to AC, so that's B, and C equal to AB, so that's C. And with C is less than B, less than A. Okay. Okay. So when the lengths are shorter, means the angle is facing would be smaller. So since the side C is shorter, so angle C would be less than angle B, would be less than angle A. Okay. And okay, let's go and switch this around. So angle A is going to be greater than or equal to angle B, greater than or equal to angle C. So angle A is the biggest angle. Okay. And so you want to prove that AX plus BY plus CZ is less than 2A plus B. Okay. So you want to prove AX plus BY plus CZ is less than 2A plus B. Okay, so we need to get each one of these. Okay. First, let's look at triangle AXC. So look at the AXC. So that is this triangle right over here. Okay. So from here you can see that the angle AXC is greater than angle B. Okay. And notice the angle B is greater than angle C, right? So this is going to be greater than or equal to angle C. Okay. And since this is the biggest angle, so this is facing that, so that means AC is facing this angle. So this is facing this. So this is facing this, and it be greater than AX. Okay. So because this is facing this is facing that. So therefore this would be greater than that. And let's look at triangle BYC. Okay. So from here, angle BYC is greater than angle A. Okay, so you can see that because angle A, when you switch down, it's going to be greater than angle A. And angle A is greater than B, greater than C. So this would be greater than equal to angle C. Okay. And so now we do the facing. So BC is facing this angle, so BC is going to be greater than BY. Okay. Again, so BY is facing angle C, BC is facing this angle Y over here. So this is facing this is facing that. Okay. So therefore, this would be greater than this. Okay. Let's look at the other triangle. Okay. Let's look at triangle CZB. Okay. So look at this triangle here now. Okay. So you have the angle CZB is greater than angle CAB. So CZB is over here. So this angle is greater than this angle here. Okay. which is angle A, and this would be greater than angle B. All right, so this is angle A, so angle A is greater than angle B. Okay, and so this is BC. So BC is facing this angle, which would be greater than CZ, which is facing this angle. Okay, so this is facing this angle, this is facing this angle. Okay, so what we're going to do is we're going to put all this together. So we got AX is less than AC. Okay, from here. This one, BY is less than BC. And over here you got CZ is less than BC. Okay. And then you add all this together. So you got AX plus BY plus CZ is less than 2BC plus AC. Okay. And if you look from here, BC is A, AC is B. Okay, so you can substitute this into here. So you got AX plus BY plus CZ is less than 2A plus B. Okay, and that's what we try to prove over here. Okay. Okay, let's go to 52. Okay, so in triangle ABC, okay, so I'm going to draw the circle first. Okay, there's A, B, C. And this is the okay. So up here you have triangle ABC. So A equal to 60 degrees, B equal to 40 degrees, and C equal to 80 degrees. If O is the center of the circumcircle of ABC, and the radius of the circle is 1, okay, so we're going to, so radius of circle is equal to 1. From the radius of the circumcircle of BOC. So you're looking for, I'm going to call this dotted line R. Okay, so you're looking for this. Okay. Okay, so if you look at triangle ABC, okay, the area of ABC equal to 1/2 AB sine C, okay, and this is also equal to ABC over 4R. Okay. From these, you can move things around, okay, and times it by 2. So you can see that sine C equal to C over 2R. Okay. Now you also get this from the law of sine. From law of sine, you got A over sine A equal to B over sine B equal to C over sine C equal to 2R. Okay. And so sine C, you flip it over. So sine C over C equal to 1 over 2R multiplied by C. So you got sine C equal to C over 2R. Okay. And so by doing the same thing, so you can see that sine B equal to B over 2R, and sine A equal to A over 2R. Okay, just from all these. Okay, so those are just some basic stuff. Okay, so with this background, okay, we can use this information. Okay, so sine A equal to A over 2R. So you can already just review. Okay, so we're going to use this one over here. And so sine of 60 degrees equal to A over 2 R is giving us 1. Okay, we can make it into 1. And so A will equal to, so times both sides by 2. Okay, so it'll be 2 sine of 60 degrees. And sine of 60 is square root of 3 over 2. Okay, so A equal to square root of 3. Okay. So once you find A equal to square root of 3, now we're going to look at triangle OBC. Okay, so look at this triangle over here, OBC. Now, if the inscribed angle is 60, then the central angle will be 120. Okay, so this angle is going to be twice as that. Okay, against, and you can see that, right? Because the inscribed angle is half of the arc, so this arc is 120. And if this is 120, this would be 120. Central angle equal to the inscribed arc. Okay, so if you look at this triangle over here, okay. So sine of angle VOC. So this is like angle A. So this angle is going to be equal. So this over. So just like this formula over here. So it'd be equal to A. So this is A. Right? So equal to A over 2R. Okay. So using the law of sine again. Okay. So sine of 120 degrees equal to square root of 3 over 2R. And sine of 120 is right over here, so again it's going to be square root of 3 over 2. So you can see the R equal to 1, or you can just cross multiply 2 square root of 3 R equal to 2 square root of 3 divided by 2 square root of 3, so R equal to 1. Okay, let's go to next one. Okay, number 53. ABC is a triangle with length of ABC, and you have the angle bisector C cut AB at D, and you want to prove that. Okay. So you got A, B, C, and the angle bisector. And so this is A, this is B, and this is C. Okay, call that X. Okay, so you want to prove that the length of CD, so you want to prove that X equal to 2AB cosine of C over 2 over A plus B. Okay, so for this, what we're going to do is let's look for start with the area of a triangle ABC. So triangle ABC equal to 1/2 AB sine of C. Right? So look at triangle ABC. Okay. Now the area of a triangle ABC is also equal to triangle AC CD plus BCD. So this the area of big triangle equal to area of this triangle plus this triangle, right? Okay, so again, area of this equal to this plus this. Okay, again, now we're going to apply this formula to this over here. Okay. Okay, so this area equal to 1/2 bx sine of this angle. So now this angle will be c over 2, right? So it'll be sine c over 2. Now this area here is going to be 1/2 ax, right? 1/2 this side times cosine sine of c over 2. Okay. Now since both of these are equal to the area ABC, so we can make these two equal to each other. Okay, so we have 1/2 AB sine C equal to 1/2 BX sine C over 2 plus 1/2 AX sine of C over 2. And we can multiply everything by 2 to get rid of the fraction. Okay, so you get AB sine C equal to, so this cancels out, okay, by multiplying by 2. So you got BX sine of C over 2 plus AX sine of C over 2. Now sine of C, we can use double angle formula. Okay, so sine C, think of this as 2 times C over 2, right? So it would be 2 sine C over 2 cosine C over 2. Okay, so it uses double angle formula. So this equal to that. So this becomes 2AB sine C over 2 cosine C over 2. Okay, so again, change this using the double angle formula for that. Okay, and what we can do next is, since you got sine of C over 2, so we can divide everything by sine of C over 2. So this can be gone. Okay. So we get 2AB cosine of C over 2 equal to BX plus AX. And next, we can go ahead and do the factoring. Okay. And then we can divide. So you got 2AB cosine of C over 2 over A plus B. Okay, and that's what we got, right? So that is done. So check. Okay. Okay, so this angle the length of the angle bisector will equal to these. Okay, let's go to the next one. Okay, so you have a triangle ABC. And CD the angle bisector. So this is just like the last one. So CD is the angle bisector. Of the angle C with D on the AB. If cosine of C over 2 equal to 1 over 3 and CD equal to 6, so this equal to 6. You want to compute 1 over A plus 1 over B equal to question mark. Okay. Okay. So first you need to recognize to find this, right? You can make it to common denominator. So this will equal to b plus a over ab. Okay, so this is equal to that. So this would be the, so again, if you write it better, so you got a plus b equal to over ab. Okay, so that's what you're looking for. Now, this one, if you notice from the last problem, notice you got a plus b over ab over here. So you're going to use this result over here. Okay. Okay. So from the previous problem, we have x equal to 2ab cosine of c over 2 over a plus b. So we're looking for this. So we're going to move things around. Okay, so we're going to cross multiply. Okay. And then we're going to move this down here and move this down here. So you're going to get a plus b over ab. So move these things down and move these things down. So you go to 2 cosine c over 2 over x. Okay? And from here, well, this is x, right? X equal to 6, so it's giving. Okay, so a plus b over ab equal to 2, and this is also giving over here. So it'd be 2 times 1 over 3 divided by 6. Okay. And so this can cancel. So a plus b over ab equal to 1 over 9. Okay, and that's it. Okay. Okay, let's go to the next one. Okay, number 55. Okay, so you have triangle ABC. And the AD and AE trisects BAC. Okay, so so this is A, B, C, D, E. And this trisect angle means all 3 angles should be congruent. Okay. And the length BD, DE, EC are 2, 3, and 6. So this is 2, 3, and 6. Okay. So you're looking for the length of the shortest side of ABC. So you're looking for which side is the shortest. Okay. So to find each one of these, we're going to call this X, and we're going to call this Y. Okay. So from triangle ABE, so look at this. So just look at this triangle over here. So apply the angle bisector theorem. So this over this equal to this over this, right? Okay. So you got AB over 2. So this over this will equal to this side of this. So it'll be y over 3. So multiply by 2. So AB equal to 2y over 3. So I'm going to put this over here. So this will equal to 2y over 3. Okay. And then we're going to look at triangle ADC. So look at this triangle here now. And we're going to do the same thing. Okay. So we're going to have this over this. So it'll be x over 3 will equal to AC over 6. Okay, so again, this over this equal to this over this. And So multiply by 6, so you got 6x over 3 equal to AC. So AC equal to 2x. Okay, we're going to put this over here. And after that, again, we're going to use triangle ABE. So now we're going to use the Stewart theorem. Okay. So this times this will be, so 2y over 3 times y. So this times this equal to this times itself plus this times this. Okay. So you got 2y squared over 3 equal to x squared plus 6. And multiply by 3. So you got 2y squared equal to 3x squared plus 18. Okay, now on this side, we're going to do the same thing. So go and look at this over here. Okay, so we're going to use this times this. This times this equal to this times itself plus this times that. So you got 2x squared equal to y squared plus 18. Let's go ahead and, so we got this two equation we need to solve. So let's go ahead and look for x. So that's going to divide by 2. So x squared equal to y squared over 2 plus 9. And I'm going to substitute this into here. So you got 2y squared equal to 3 times y squared over 2 plus 9 plus 18. Okay. So that's going to work it out. So we got 2y squared equal to 3y squared over 2 plus 27 plus 18. And okay, so let's go ahead and multiply 18 by 2 to give it a fraction. So I get 4y squared equal to 3y squared plus 54 plus 36. Okay, so minus y squared on minus 3y squared on both sides. So you get y squared equal to 90. Take the square root, so y equal to 3 square root of 10. Okay. Okay, so that's a good information. So once we find y, we can substitute into here. Okay. Now instead of substitute back in, let's go and do the y squared. See, y squared equal to 90, so substitute this into here. So x squared equal to 90 over 2 plus 9. So x squared equal to 45 plus 9. So x squared equal to 54. Take the square root, so x equal to square root of 54. So x will equal to 3 square root of 6. Okay. Okay, so once we find x and y, now we can find we can find what we're looking for. Okay, we can look for each side. Okay. Okay, so AB equal to 2y over 3. So AB equal to 2 times 3 square root of 10 over 3. So AB equal to 2 square root of 10. Okay. And AC equal to 2x. So AC equal to 2 times 3 square root of 6. So AC equal to 6 square root of 6. Okay. And BC equal to, well, this one is obvious, equal to 12. Okay. So by looking at this is about 3, so this is about 6. So obviously this is going to be shorter than that. So AB is the shortest. So answer is AB. Okay. This is 55. Okay, let's go to the next one. Okay, so you have a triangle. You got triangle ABC, and you have the median. So median goes to the midpoint. Okay. And it says, and is it reflected on its median AM? So here's your line of reflection. Now when you're doing a reflection, okay, what you do is you draw the perpendicular line. Drawing perpendicular line, and you measure the same distance. So that's how you do the reflection. So this is 3.5. Could be right over here. So this would be the B prime. Now A, when you reflect over itself, this is still the A prime. Okay? And for C, okay, so measure. Oh, here. So this will be a C prime. Okay. Okay. So let's go ahead, and I'm going to highlight this using different color, so it's more, so it'd be less confusing. Okay, so that is the blue, and then we have the red. Okay. Okay, so let's start. So M is the midpoint of BC, because we reflect over. So that the area ABM equal to area of a triangle AMC. So since this is the midpoint, okay, so this area over here is going to be equal to this area right over here. Right, because this is the midpoint, so you got the same base, same height, so these two areas are going to be equal. Okay. And the area ADM, and so this is a point D right over here, and this is a point E right over here. Okay. So the area of ADM, that is this one right over here. Okay. It's going to be equal to the area of AME. Okay, which is equal to this area right over here. Okay, so these two areas are congruent. Okay. Okay, because of reflection. Okay. Now, if you subtract this over here, So this minus that will give you area of A, B, D. Okay. Now this side, the blue half minus that will give you area of M, E, C. Okay. So again, this half and this half are equal. So this half minus that give you that. This half minus that give you that. Okay. So now, so you can see that now I'm going to erase this over here. So now this area is going to equal to this area right over here. Okay? And because of reflection, this area is equal to this area. Okay? Okay, so it would be M, D, C prime. Okay. Okay. Okay, so when we reflect over, this will give you this equal to area right over here. Okay. So this all three areas are equal. Okay. And now there are also some information giving the AE equal to 6. So A equal to 6, that means AD equal to 6, right? Because the reflection. EC equal to 12. So EC equal to 12, that means this will equal to 12. So DC prime equal to 12. BD equal to 10, so BD equal to 10, so that's 10 right over here. Okay. And AB equal to K square root of 3. Okay. Okay, so now we have all the background work ready. So now we're going to do, we're going to start to work on these, okay? So the triangle ABD, this triangle over here, is equal, so this equal to 1/2 BD, okay, 1/2 B. So again, we're looking at this triangle right over here. Okay, so the area of the triangle will be 1/2 BD times AM sine of angle. Let's see what. Okay, BD. BDAT. Okay, we're looking at this triangle right over here. Okay, so triangle ABD. There we go. Okay, so look at triangle ABD. So it'd be 1/2 AB times AD sine of angle B. Okay. Okay, BDAD. So we need to look at angle BDA. There you go. Okay. Okay, let's see. Okay, BDAD. Okay. You know, let's do this. Let's do the AB and BD. So AB and BD. So yeah, okay, that's fine. Okay, so BD and AD. Okay, let's do the BD and because we know these two, right? Okay. Okay, and it'll be angle. Let's see. I'm trying to see which would be a better idea. Okay, yeah, okay, let's go and do this triangle using this angle here. Okay, so you have 1/2 BD AD sine of ADB or BDA. Okay, that's fine. Okay, so we're looking at this triangle here, and so now we're going to look at this triangle here now. So this will equal to 1/2 1/2 dc prime times dm times sine of this angle here, angle c prime dm. Okay, there we go. Okay, so again we're using this. Okay, so this is the area for this triangle. This is the area for this triangle. Okay, so that's what we're doing. Okay. And what we're going to do next is, okay, now since these two are vertical angles, so sine of them would be equal. Okay, so these two are equal because they are vertical angles. Okay, vertical angles are congruent, and when you take the sine of congruent angle, they're equal. So this and this will cancel out, and 1/2 will cancel out. Okay, so we have BD times AD equal to DC prime times dm. And we know some of these numbers. We know that BD equal to 10 and AD is equal to 6. Okay, DC prime equal to 12 and dm we don't know. Oh, dm. Okay, so divide by 12, divide by 12. So dm equal to dm equal to 5. Okay, so dm equal to 5. There you go. Okay, now once we find that, okay, now we can go back and we can find the cosine of that and substitute into here. Okay. Okay, so we're going to need another sheet of paper. Okay, so now we're going to look at triangle C prime dm. Okay, so look at this triangle here and use law of cosine. Okay, so law of cosine we're going to apply to this angle right over here. Okay, so we're going to get C prime dm. Oh, okay. So by using the symmetry, okay, because this is the midpoint, okay, so this is 10, this is 5, so this will be a 15. Okay, so look over here. So BD equal to 5 and DM equal to BD equal to 10 and DM equal to 5. So BM equal to 15, and therefore MC equal to 15 because this is the midpoint. Okay, so this is 10, this is 5, so this is 15, so this is equal to 15. Okay, now if this is 15, when you reflect over, so C prime M equal to MC, okay, so also equal to 15. So this is also equal to 15. Okay, so once we find all these, we can apply to get this angle over here. Okay. Okay, so for this angle right over here, we're going to start with this. So we get 15 square. So 15 square equal to 12 square plus 5 square minus 2 times 12 times 5 cosine of angle C prime dm. Okay, so again we apply the law of cosine for this angle here. So again, so you're going to get, so think of this as angle C, right? So you're going to get C squared equal to A squared plus B squared minus 2BC cosine of C. Okay. And then we can find what this is because we know everything else, right? Okay. Okay, so cosine of angle C prime dm equal to, so we're going to move this over, so you're going to get 225